Hello everybody, my name is not Topher. It is Mr. Folly. And I want to show you the last part of Big Idea 5. And I've been cooking right through this one. So we're going to look at reaction energy profiles, or what they call it. Okay, I call them PE diagrams. PE diagrams. And the reason why is these are potential energy. This is potential energy through most of this. Okay, so we're going to look very closely at this, and we're going to look at some different things we can pick up from these graphs. All right, so first of all, I'm going to start with the red. This is the activation energy. The activation energy, well, this is starting materials, but no one calls it starting materials. Let's be honest, we call it reactants. Okay, so I make my reactants look more like an S. Okay, so I start with my reactants and it goes up. How much does it go up? That's the activation energy. This is often called the energy barrier that must be overcome. Okay, I'm going to get rid of the word rate limiting. I just stole this off of here. This says TS, which is the transition state. Now, the reason that said rate limiting is this is the rate determining step. Okay, so this is the rate determining transition state. Remember, rate determining means it's slow. Okay, because that's the highest activation energy. This is the non-limiting transition state. Why? Because it took less energy, so it's faster. So what takes longer? Let's see if I can get rid of this, make my life a little easier. What takes longer, running up the green or running up the yellow? Okay, running up the green takes longer, so that's the rate determining part of it. Okay, there you go. Okay, reactants are the starting materials. They're found on the left. They may include catalysts. Okay, products, the ending materials, they're found on the right. They may include catalysts. The transition state is the highest peaks. Unstable is bad, Lewis dot. So that means they're unstable. So if you have a bad Lewis dot, it doesn't exist for very long. It falls apart. These transition states indicate the number of steps in the reaction. So above, I had 2 transition states. I had 2 peaks. Equals 2 steps. The highest transition state is the slowest step. Slow step is the rate determining step. Activation energy is the energy from the reactants to the highest transition state, not from 0 to the highest transition state. All right, little delta H fun. Okay, so delta H is the energy of a reaction. Okay, it is the bond energy that happens. So let's take a look up here. Bond energy. Up here, this is where bonds break. Ow, 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 ow. It hurts running up a hill. Coming down a hill is where bonds form. And just to remind you, bark, you thought you wouldn't hear it after the break, you're wrong. Breaking absorbs energy. Look, my energy's going up. I'm absorbing energy as I break those bonds. And releasing energy. I have high energy, low energy, it's released, forms bonds. Okay. If you end low, it's exothermic. If you end high, it's endothermic. And let me just show you that. Okay, so this has a bunch of stuff on here. I just want you to look at what I'm focusing on right now. So first of all, exothermic versus endothermic. This is exo because here's my reactants, here's my products. Delta H went down. This is endo. Here's my reactants. It went up to my products. That's an up arrow. So delta H is positive. In this one, delta H is negative. Okay, and sometimes they put numbers with that. Okay. Next thing I want to show you is watching us. I guess use my highlighter. Oh no, let's make it nice and big. And ooh, we can be lime green and living large in lime. Whoa! That's a high transition state. I don't like my transition state to be so high, so I'll use a catalyst. And notice how my transition state is lower, and that means it's easier. Okay. So the transition state without the catalyst, right here, transition state with the catalyst, notice it's lower. The activation energy without the catalyst, wow, that's enormous. That reaction must be slow. This is the activation energy with catalyst must be most fast. Whoop, I'm up and down, I'm down. Okay. And then this is the change in energy. And all we're going to call it right now is delta H. Okay. That's it. That's it. I'm done. Toodles. Let's see if this works as well as I want it to. Uh-oh.